Okay, so in this video we're going to look at another type of chemical reaction. This one is combustion.
Combustion reactions are simply reactions where a fuel reacts with oxygen to produce heat and light along with a byproduct, which is usually an oxide compound. The chemical equation for these reactions are slightly different depending on the fuel that you're using. For example, if the fuel is a hydrocarbon, then the equation generally looks like this, or it looks like this. Note, for simplicity, these equations are not balanced, and so you'll need to make sure that you balance them yourself when you're finished. And the letters X, Y, and Z are placeholders for numbers that will depend on the hydrocarbon you are using. The pattern here is that for both rules, the hydrocarbon being burnt will always produce carbon dioxide and water. For example, if we look at the combustion of propane, we can see that the products, we can predict them using the general rule. And we put in our formula for propane, and we finish it off by balancing it. Sometimes the hydrocarbon has a little bit of oxygen inside, such as for an alcohol, ketone, or an aldehyde compound. So we can see how the rule works with something simple like, let's choose ethanol. We start with our rule, and we put in the formula for ethanol, and now we balance the equation. Lastly, sometimes the fuel in the combustion reaction can actually be a metal, such as magnesium. It burns quite well. Note that there is no carbon dioxide byproduct at this time. And it kind of makes sense because with hydrocarbons, we have carbon to work with, therefore to make a carbon dioxide product. But in this occasion, we don't have any carbon, so we can only make a metal oxide compound. Which brings us back to the basic rule I had at the beginning, where I said a fuel plus some oxygen will react to form some energy and something oxide.
One thing that we can see is that if the combustion is incomplete combustion, we are basically not being at 100% efficiency. So here I've closed the barrel of the Bunsen burner, so I'm starving it of oxygen. And so not all of the propane or butane or whatever it is, not all of the hydrocarbon fuel is actually getting access to the oxygen. It can only get access to oxygen that's nearby, so some of it is only half combusted. So when you fully combust, you'll get carbon dioxide, the fuel oxide, and you'll have something in between where you can have carbon monoxide, and you can have just ordinary soot, which in this case will be carbon. So yellow flame, safety flame, it tends to have little bits of residue of that black soot. That's what I got here. It's a very cool flame relative to the other type here, and we're just having some of that leftover unburnt fuel, and that's that black carbon soot that's incompletely combusted. We can have complete combustion, so if I open up the barrel, I can allow oxygen to pass in from underneath, and then now we're basically giving all the oxygen that this flame needs to combust completely. So we get a cleaner flame. We don't get so much of that soot production, so it's a very clean, burns all the fuel, very little carbon monoxide, very little at all soot left over. But that's kind of boring. Let's go look at something a bit more interesting here. Let's combust magnesium. All right, and there it goes. So I'm turning my attention away from this bit here. And we can see that we get a very bright white flame. You can use it in fire starters, I believe, has a bit of magnesium, so you can scratch that and start a campfire. We'll use a little bits of it, I think, in sparklers if you're doing things at New Year's Eve. And you probably have some of this metal also being used in fireworks to give that bright white color pattern when the firework goes off.
I hope you enjoyed the video. I realize it finished a little bit abrupt. Things didn't go to plan when I was filming on the day, so hence a lot of the voiceovers you're hearing right now. But to end things on a lighter note, thought I'd just throw in a bunch of miscellaneous footage that I've collected over the years of things combusting, so I hope you enjoy them.
Two. Three, two, one.